what I found over the years is the more we know about a body in space, the harder it is to believe the evolutionary stories. Evolution in a way thrives on ignorance. The less we know about something, the more plausible evolution seems and the evolutionary story seems. But the more data we get about these bodies in space, the more problems it creates for these old universe scenarios.
Hello, everyone. Welcome to the Creation Podcast, the show where we discuss the science that confirms Scripture. I'm your host, Lauren, and I have with me today ICR scientist, Dr. Jake Hebert. Thank you so much for being with us today.
Thanks for having me. Yeah.
It's always good to have you, Dr. Hebert. Our conversations are always encouraging to me, and I'm sure our viewers and listeners feel the same way. So I'm eager for today's topic. So what we're talking about today, obviously, a lot of us are passionate about the solar system and just learning about those different planets. I've heard some people offended on Pluto's behalf and all of that. Mm-hmm. But specifically today, we want to focus on Jupiter. Specifically, its moons. Jupiter has a lot of moons, I believe 95.
Yeah, I think that's about right.
Yeah, a lot of moons. The four largest of those were actually discovered by Galileo back in the early 1600s, I think 1610, if I'm not mistaken. And those are called the Galilean moons because of that. That's what we're going to be focusing on today. And all four of those moons are unique, and they all seem quite young. So we're going to talk a little bit about each of those today. But first off, why does it matter? Why does it matter that these moons look so young? Can you talk a little bit about what conventional scientists say about the age of our solar system?
Well, they say that it's about 4.6 billion years old. And of course, they say the universe is even older than that, 13.8 billion years old. But you don't see any hint of millions or billions of years in Scripture. And so really, this is an issue of, can we trust what the Bible is saying? Is the Bible getting, the early history of our universe correct, or is it getting it wrong? And so it's really an issue about, can we really trust our Bibles? And so as creationists, we get excited whenever we see indications of youth, because I want to point out here, basically what we're doing is we show that even when you make assumptions that are favorable to the old universe or old solar system position, you get these contradictions. You get things that don't make sense. And so that's how these young universe arguments work. We're not assuming, a young universe and using that to prove a young universe. We're taking, even when you take your starting assumptions that are favorable to the evolutionary story, uniformitarianism, things like that, you still have problems. You still find that many of these objects are much too young to comfortably fit into the story they're telling. And of course, because you're making uniformitarian assumptions, if you were to get rid of the uniformitarian assumptions and use biblical assumptions, then the ages could actually be even less than that, consistent with the 6,000-year-old universe. So that's why we think this is a big deal, because it's showing us that the Bible is getting its history right.
Right, and if it gets its history right, then there's a good reason to believe it gets the rest right. But if it gets its history wrong...
Right. So yeah, if you can't trust the first 11 chapters of Genesis, why should you trust the New Testament when it tells us that Jesus is the Son of God? Mm-hmm. And that's really the bottom line. And so it's a question of, can we trust the Bible when it tells us about spiritual things? Yeah.
Absolutely. And that's the important reason. And another reason is it's really fun to talk about this stuff. So
it is.
This will be great. So we're talking about warm celestial bodies. That's really what we're talking about here. And that's what we mean by young. Because a lot of people are like, what do you mean it looks young?
Right.
What we're really talking about is energy. And can you talk just a little bit about that in general before we dive into these specific moons?
Right. It turns out that small bodies lose their energy to space pretty quickly. And so if you see a small warm body, there's only a few mechanisms that can provide warmth for long periods of time. One of those is radioactive decay. If you get heat generated by radioactive decay of these heavy elements. Another one is that there's something called tidal flexing, where you have these gravitational tugs on a body where it compresses and flexes the interior, and that generates heat. That's one way to do it. Or you can have just leftover primordial heat from its creation. Now, the problem for evolutionists is that in some cases, the mechanisms that they would want to invoke to explain why these small bodies are still warm don't work. For instance, if you look at radioactivity, these heavy radioactive elements are very dense. But if you look at the sizes of some of these things and their inferred densities, that doesn't work. So in some cases, there's no real plausible mechanism to explain how a small body could stay warm for billions of years. And if that's it, the only thing left is that it's still cooling off. Well, if you believe it's billions of years old, that doesn't work because it should have already, basically.
It's ice cold by this point.
Yes, exactly. But if it's just thousands of years old, it could still be cooling off. And so when we see warm small bodies, that often, not always, but often is an indication of youth.
Okay.
Because there's not a viable mechanism to explain how it could stay warm for all that time.
Okay, thank you. That's helpful background. And remember that, viewers and listeners, because we're gonna hear more about that as we dive into these specific moons. So first is Io, or some people call it Io. You can use either one. We see both used. Right. So let's talk about that. There's a lot of volcanic activity on Io. Can you talk a little bit about that?
Yeah, Io is the most volcanic body in the solar system. It's got all these volcanoes, and there's got so much volcanic activity that they think Io should have basically turned itself inside out more than 100 times over the last 4.6 billion years, and that's excessive. Now, for the evolutionist, they don't think radioactivity can explain the volcanism on Io. Okay, they think it may contribute a little, but not much. So they're dependent on tidal flexing to try to explain the volcanism on Io. Well, for a long time, we creationists pointed out that they could not generate enough. Okay, you could get some heat from tidal flexing, but not enough to account for all of what was going on.
And what is tidal flexing?
Well, it's just gravitational tugs that kind of squish, compress, flex the interior. It's like if you take a rubber ball and you kind of do this to it, you can warm it up.
Okay.
Same idea, but instead it's the gravitational tugs that are doing that to the body. Okay, like you might have Jupiter. Jupiter can be exerting gravitational tugs on Io, and that's doing that. Now, it turns out recently they've said, when they were originally doing these calculations, they didn't think that gravitational tugs from the other moons made much of a difference. But now they're thinking, well, it could. In some cases, it could. If you had a liquid magma ocean, that might be significant. So I would caution about being dogmatic on this point because nobody really knows. They think maybe tidal flexing might work if certain things hold true in the interior, but we don't know if those things hold true or not. But the bottom line is, no matter how you slice it, volcanism on Io is improbable. Okay, because for one thing, you would think, let's say you assume that the volcanism has been going on for billions of years. Well, when that process goes on over and over and over again, and it's basically turning itself inside out, the heavy elements in the interior ought to sink to the bottom. Okay, now the crust of Io is what they call mafic or ultramafic crust. It's got a lot of magnesium.
Okay.
Well, that magnesium should have settled out a long time ago, and it should be depleted in magnesium if this process has been going on for billions of years. But that's not the case.
There's still a lot there.
There's still a lot there. Okay, so that would suggest that this is probably hasn't been going on for billions of years. Now, some of them think, well, maybe we could explain that if you had a completely liquid core and a crystal-rich magma ocean. Now, I'm not going to get into the details on that, but some of the experts think that might work. But we don't know if that's true. And other mainstream scientists dispute both of those things. So we don't really have a good explanation. If you believe Io has been undergoing this volcanism for billions of years, we don't have a good explanation for why it's still enriched in magnesium. Now, the other thing you could say is, well, maybe the volcanism is just recent. Maybe it hasn't been erupting this violently all this time, but it just started in the recent past. Well, that's potentially problematic because that would imply a remarkable coincidence. Maybe one coincidence is okay. We're seeing a short-lived phenomenon, but it makes mainstream scientists nervous when you see many examples of this. And we see lots of examples of this in the solar system.
Too many coincidences.
Too many short-lived phenomena that are we just really lucky and we just all happen to be seeing them? Why is it that we just happen to be looking at just the right time and just the right place to be seeing these things? Saturn's rings, they're short-lived. They don't think they're very old, and they don't think they can last very long either. Maybe a few 100 million years, something like that, compared to 4.5 billion years. When you start seeing many examples of this, what should be short-lived phenomena all happening at the same time, they don't like that. So any way you slice it, there's a problem for them with EO. Regardless of whether you try to say it's been going on for billions of years, would that even work? Okay, would it work? And even if it did work, how do you explain the fact that there's so much magnesium in the crust? Mm-hmm. And then if you say, well, no, it just started erupting recently, well, why are we lucky to be seeing that coincidentally? So that's the kind of thing that confronts mainstream scientists when they see something like EO. No matter how you slice it, it's a problem for the idea of billions of years.
The best explanation is that the biblical timeline makes sense and that it's young.
Yeah, you don't have those problems if you just say, oh, hey, it's young. It's young. In that case, it could still be cooling off with some of that original primordial energy that God gave it. Mm-hmm. So we don't have a problem, but they do. And it's not just EO. There's lots of other examples of this.
But they're still trying to fit that in with their preconceived notion of billions of years.
Yes, and of course they're wanting to. They're sending probes to the moons of Jupiter, especially Europa, and we could talk about that in a second. What I've found over the years is the more we know about a body in space, the harder it is to believe the evolutionary stories. Evolution in a way thrives on ignorance. The less we know about something, the more plausible evolution seems and the evolutionary story seems. But the more data we get about these bodies in space, the more problems it creates for these old universe scenarios.
Can we talk a little bit? One question we get sometimes from commenters on social media and on YouTube and other places as well is people ask what evolution has to do with astronomy.
Right.
And because a lot of people associate evolution with purely biological processes. Can you talk just very briefly, just as a helpful background, why is this important? Why do we talk about evolution when we're talking about astronomy?
Well, the thing is, in order for the evolutionary, biological evolutionary story to hold, you need deep time. So if the solar system is young, evolution can't happen. So there's a close connection. Remember, evolution in its broadest sense is supposed to be a comprehensive story of everything. I mean, it's a competing religion with Christianity. They're purporting to have an answer for everything. It's supposed to. There's nothing that's outside the domain of evolution. It's supposed to explain everything. So, it's all part of this big evolutionary story. And so, I think people say, oh, well, we're not talking about biological evolution. Well, in a way we are, because when we get to Europa, they want to find life on Europa, okay? And we can get into that when we start talking about Europa. But it's all part of this big story. So some people have quibbled about using the word evolution in an astronomical context, but evolutionists themselves use it all the time. So it's not unfair to talk about evolution in this context because it's all part of this big story.
Absolutely. Thank you.
Sure.
Let's go ahead and move on to Europa. You mentioned it a couple times a minute ago. So Europa, well, you know what? I'll let you share. What looks young about Europa?
Well, Europa, it's very smooth, and it looks like they think there's good reasons to think it has a subsurface ocean, water. And it's not just Europa. They think Enceladus, one of the moons of Saturn. They think there's strong evidence for that as well. And a lot of evolutionary scientists think that there might be another dozen or so moons in the solar system that could have subsurface oceans. But the evidence for those subsurface oceans is strongest for Europa and for Enceladus.
And what is a subsurface ocean?
Well, it's just basically, it's almost like a stealth ocean. It's hidden beneath the crust. You know, it's like an ocean that's inside the interior, so you can't see it from the outside, but it's inside. And now they want so much to find evidence of life in space because they think that will make the evolution story seem more believable. In fact, there's a mission called the Europa Clipper mission where it was supposed to have already been launched in October, but it looks like they're going to launch it next year. But this is what one of the scientists, the project scientist, said about this Europa Clipper mission. He said, if there's life on Europa, it almost certainly was completely independent from the origin of life on Earth. That would mean the origin of life must be pretty easy throughout the galaxy and beyond. So they think that if they find life on Europa, that will show that the evolutionary story is plausible. Now, I think that's bad logic because they don't have a clue how life would begin. In fact, the well-known chemist from Rice University, James Tour, he recently challenged 10 prominent origin of life researchers to answer just one of 5 main problems that they have in their field. He gave them 60 days, and there were no takers. Now, interestingly enough, they're supposed to be having a Harvard roundtable about that today, I believe, but I don't think it's going to be. It's not public. It's not open access. But it'll be interesting to see what comes from that. So, but anyway, it's bad logic. You know, Spike Basaris, who's done a really good series of DVDs on this subject about our solar system, he says, look, I mean, you basically need a miracle to explain life. So even if you did have life on Europa, that means you need 2 miracles now. So it's kind of
more coincidences.
Yeah. And now I don't expect we're going to find life there, and I for sure don't think you're going to find intelligent life in space. But they want very much to find it, and that's why, because they think it's going to make the story seem plausible. So even though they have no clue how it could have happened, they think that if they can find evidence of life on Europa or anywhere else for that matter, that will sort of be a proof of concept that evolution can happen even though they don't have a clue how it could happen.
And they think seeing signs of water or a subsurface ocean indicates there could be life there. Is that kind of what you're saying?
Yes. Now, it's a bad argument because, first of all, you need life. I mean, you need water for life, but water is it's a necessary but not a sufficient condition. Mm-hmm. And water tends to destroy biomolecules, over time. So, they're saying these things originated in some primordial soup. Water is eventually going to, destroy that stuff. So it's way too simplistic to say that just because you've got water, that shows that life could evolve. Now, here's the interesting thing, though. As creationists, I think we should be excited if it turns out that Europa has a liquid ocean, because that's hard to explain if you believe it's billions of years old. Because people who've looked at this, I told you about this newer idea of tidal flexing where they're thinking the moons can also make a difference. Mm-hmm. Well, the guy who did that research, he said, it takes a delicate balance to maintain a subsurface liquid ocean for billions of years. So it's almost like you're trying to, the heat in, it's got to just balance the heat out so that you can have a liquid ocean. What are the odds that could be going on for billions of years? And if you say, okay, well, it was solid, but it just recently became a liquid, well, again, you got the same problem. What a coincidence that we happen to be seeing this at just the right time. So I'm hoping they do find liquid water beneath the surface of Europa and Enceladus, because it's easy for us as creationists when they want so badly to find life in outer space. We kind of roll our eyes when they talk about, oh yeah, right, water. But even though their motivation is wrong, they could actually end up helping the creationist movement, because a subsurface liquid ocean on Europa or Enceladus is easier to explain in a young solar system than it is in an old solar system. And what if, say, that it turns out there's more than those two? A lot of these guys think there might be subsurface oceans all over the place, maybe a dozen or so additional moons that could have these. Now, some of that may be wishful thinking on their part because they desperately want to find evidence for life or this evidence that life can evolve. But what if you do? What if you do find? What if you've got like 6 moons in our solar system that have liquid subsurface oceans? What are the odds? Again, that would be another strong argument that these bodies are young.
Absolutely.
Because it's very hard to maintain just the right amount of heat to maintain that liquid ocean.
So there was one word that you said repeatedly that struck me again and again. You said liquid. That means Europa cannot be as icy cold as it would be. Is it still warm?
Well, it's obviously it's going to be cold, but not so cold that you can have that. That's the idea. The problem for them is that, you would expect it to freeze. How it's like you're trying to balance on a knife edge. It either melts, okay, or it freezes. And how do you maintain the heat for billions of years, getting it just right so that you could maintain a liquid ocean? It's kind of like trying to balance on a knife edge, especially if you're doing it for billions of years. And even the mainstream scientists have acknowledged that's tough to explain. Now, they just take it on faith that it's happened because they believe the solar system is billions of years old. But it's tough to explain. It's much easier to explain a subsurface ocean on a place like Europa or Enceladus if those moons are young. Then you don't have to balance the heat precisely for all that time.
It takes away a lot of the coincidence.
Yes, it does. It
Absolutely.
does. Right.
Well, we're going to take a step back from our main topic, and it's time for our random science question of the day.
Okay.
So today our question is, we know that moons are important for our planet. Our moon is very important for our planet. It has a lot of different functions. Why do some planets have so many moons? And what is the purpose of a moon in planets that don't have life?
Right. I can think of 2 reasons. One, I think God just did it to make things that are beautiful. They're beautiful. These moons are beautiful to look at. But there's another reason, I think, and I think part of it is to confound evolutionists' attempt to explain the solar system apart from a miracle. And I'll give you an example. The moons of Saturn really, really trouble evolutionary scientists because Saturn, like Jupiter, has a lot of moons. Maybe 83 moons or something like that. And you got to remember that because of this thing called tidal flexing, they think that the moons are either moving away from their planets or moving toward their planets. Now, the problem for them is telling a consistent story over billions of years. And the problem is this, every time you add motion, every time you add another moving part to the story, it gets more complicated and it becomes harder and harder to tell a story that doesn't contradict itself in somehow. So for instance, recently some of these moons of Saturn, they found that they think they're moving farther away much faster than they really were. Well, the problem for them is that most of their origin stories about these moons assume that they formed close to their present-day locations. Well, apparently not, okay? So, remember, because, they don't stay static, okay? Because of this tidal flexing phenomenon, one of the side effects of that is that these moons will either move gradually inward toward the planet or farther away. So it's not a static system. And so even if you can account, let's say even if you can get the tidal flexing to work to maintain the heat that you need in some of these scenarios, the amount of motion may contradict the story in another way. So every time you add motion in fact, that's exactly what one of these astronomers said. He said, every time you add motion to the system, and he was in particular talking about Saturn, older moons become harder to have. And so that's one of the reasons that many mainstream scientists try to argue that Saturn's moons are young, but they have a really hard time explaining young moons. It's very closely related to the problem with Saturn's rings. They want to believe that the rings are old, but they have been forced to acknowledge that they're young. But it's hard for them to explain how the rings could have formed recently if they're young. So there's all these problems. So I think one of the reasons God did that is just simply the beauty of these celestial bodies. But the other reason, I think, is he deliberately did it to confound their attempts to try to explain our existence apart from a creator. Because the more motion you have in these systems, the harder it is to tell a story that doesn't contradict itself in some way.
As much as they try, they can't shut God out of the picture.
Right, that's right.
He refuses to be shut out of the picture. I love
Yes.
that. Thank you.
Yeah,
that was
sure.
a great answer.
Okay.
So that was our random science question of the
Right.
day.
Okay.
So we'll kind of jump back into the topic at hand with the next moon that we're going to discuss today, Ganymede. Am I saying that correctly?
Yes.
Okay, so Ganymede, to my understanding, is the largest of these Galilean moons.
Yes.
And it has, in particular, one surprising feature. Can you talk a little bit about
Right.
that?
Ganymede has, they think, its own internally generated magnetic field. Now, they were surprised by that. When they discovered this from the space probes, they were shocked because this all gets into this issue of planetary magnetism. Evolutionists believe that these bodies have maintained magnetic fields for billions of years. Well, all magnetism is caused by moving electrical currents. The problem is that electrical currents run down over time. And so, you would expect that these electrical currents to die down and you shouldn't have a magnetic field anymore. Now, the way they try to get around that is they have something called a dynamo theory that's very complicated. And the idea is that somehow you've got this internally generated current that can self-sustain it for billions of years. Well, they've been working on this theory for a century. It still doesn't work. I don't think it'll ever work. But interestingly enough, even with the dynamo theory, in some cases, they would like to invoke a dynamo theory for Ganymede, but it doesn't work for Ganymede.
Why not?
Because Ganymede is too far away for tidal flexing to be a source of heat. And I think also the radioactivity is really not sufficient. So they've got no mechanism to explain how Ganymede has a magnetic field. It's very similar to it's similar to what you have with Mercury. They were surprised that Mercury had a magnetic field. So what they're doing now is they're trying to come up with alternate explanations for how Ganymede could have a magnetic field. So remember, to have a magnetic field, you've got to have a moving, electrically conducting current. So what they think, a lot of times this current is driven by differences in temperature. We know that hot air rises and cold air sinks, so you can have temperature differences that can set up these motions, these movement of fluids that can maybe theoretically generate a magnetic field. Oh, again, they've never been able to get it to work, but that's the idea.
Yeah.
That's the idea. So here, that doesn't really work because you would expect it to cool off pretty quickly because Ganymede's relative. It's big, but it's not big enough.
Big for a moon, but it's not.
Right. So now they're saying, well, maybe you could have density differences that are due to differences in chemical composition, not necessarily temperature. So they've got two main ideas. One is this idea that you could have snow, iron snow, where it's precipitating down from the top of the core down to the inner core, and then when it gets far enough down, it melts, and this is supposed to set up these convection currents. So you've got moving electrically conducting currents, but it's not necessarily. Supposedly, this would work for a long time. Well, it turns out that mechanism, even under the best scenario, it can only provide the convection for about 800 million years, which is not all that long. Now, they've got another similar mechanism called sort of an iron sulfide layer, where they think the core is freezing from the outside in. Now, Earth, we've got a solid interior core and a liquid outer core. For Ganymede, they're proposing that you've got a solid outer core and a liquid inner core, and that it's freezing this way.
Okay.
And that, too, is supposed to set up these currents, these electrically conducting currents that can give you a magnetic field. Well, there's at least one major problem with that. One, you need a lot of sulfur for that to work. You need the core to initially have about 36% of its weight be sulfur.
Is that a reasonable expectation?
Well, probably not. That's pretty high, and I suspect that would contradict. Even the evolutionists have said that could contradict their scenarios about how the moons and the planets were formed.
Okay. Again, those contradictions.
Another problem, though, and this is something that Wayne Spencer, who's a creation researcher who's done a lot on the solar system and comets and things of this nature, he's pointed out, look, sulfur is an insulator. The more sulfur you have here, there's a chance it may not be electrically conducting enough for this even to work. So there's all kinds of problems. And now this mechanism might, even under their best scenario, it could go for 3.8 billion years. But again, you need a lot of sulfur, which may not be realistic just given their origin scenarios.
Right.
And then also on top of that, if you have that much sulfur, is it going to be conducting enough, electrically conducting enough for this to work? So, the simplest explanation in this is that Ganymede is young. It hasn't yet completely cooled off, and it's still got a magnetic field. And so, again, they're always coming. You will often see these attempts to try to get around these difficulties, but what you find is that usually, when you dig beneath the surface, those explanations don't work. And in some cases, maybe they could work, but they only work if certain conditions hold, and we don't even know if those conditions hold or not.
Or they present more problems than they solve.
Yes, and so this is why I think it's great that we're getting more data. The more probes we send to Jupiter, like this Europa Clipper mission, I think the more we're going to learn, the harder it's going to be for them to argue that these moons are billions of years old. Because there's a verse in Scripture. This is the wrath of man shall praise you, referring to God. And God makes even the wrath of man to praise him. So even though these scientists, many of them are trying to prove that we don't need a creator to explain our existence, and they're spending billions of dollars on that, what usually happens, they end up making a stronger case for creation inadvertently. And so, I think it'll be great to get more data from these space probes.
Well, because you can say whatever you want, but the reality is still going to show what the reality says.
Right. The more you learn, that puts tighter and tighter constraints on the scenarios that you can propose, and some of them get ruled out. So there may be some scenarios they have right now that are plausible, but when you get more data, you're going to find, no, that doesn't work because you don't have the necessary conditions for that to work.
Or it contradicts this other part, this essential part of your theory, there keeps being contradictions, assumptions,
right,
too many coincidences.
So the simplest explanation is that Ganymede's young. It just hasn't cooled off yet, and it's got a relatively warm interior, and that's how it's got a magnetic field.
Absolutely. Yeah. Wow. Okay, so we've covered 3 so far. On to the last one. We're going to talk a little bit about Callisto.
Right.
So that is, to my understanding, the most heavily cratered object that we know of in the solar system.
Right, that's true.
And a lot of people assume that means age.
Yes.
What are your thoughts?
Well, it's not really a great argument for age, but they do. They ascend, and this is not totally unreasonable. Obviously, you expect craters to accumulate over time. So you have more craters, you might say, okay, this is older than something that has fewer craters. But the thing is, you're making uniformitarian assumptions. They use the moon. They use the cratering on the moon to calibrate.
Like our moon, you mean?
Yes, our moon. They use that, they think they know the moon is 4.5, almost as old as the Earth, billion years old. So they think they can use that to calibrate the cratering rates. But there's all kinds of problems with that. For instance, they've realized that some of these things, you get secondary craters. Like when you have an impact, there's debris that comes up and makes other craters. And that complicates the analysis. So, I don't think that's a particularly strong argument that it's old. And there's even some indications that suggest youth. They found around 2001, they began to suspect that maybe Callisto has a molten interior. But they were thinking, well, radioactivity could maybe provide that, but they thought it would cool and freeze in a few 100 million years. So they were surprised by that. Now, I think the evidence for youth in these 4 Galilean moons is probably the weakest for Callisto. I think Io, Ganymede, and Europa are potentially much stronger arguments. But even with Callisto, there's some things about it that are suggestive of youth. And so, really all 4 of these Galilean moons are silently testifying that they're young and their solar system is young.
Well, even with the molten interior that you mentioned, that wouldn't be possible if it had been around for as long as it supposedly has been around.
Right.
Do they have they can't just ignore that. Do they have any theories that try to explain that away?
Well, I don't know if they do it. You mean for Callisto?
Specifically for Callisto. Like
Yeah,
I heard something about antifreeze theory.
Well, yes, they do. They speculate that maybe if you have certain chemicals in that subsurface ocean, it would act like an antifreeze and keep it from freezing. Well, maybe. Okay, but again, we don't know what's in the interior. You can throw out all kinds of plausible sounding stuff, but when you get more data, then you start saying, okay, this is not going to work. And that's something I would caution our listeners about. You know, you will routinely have in the popular science press evolutionists claiming to solve certain problems, and I've noticed they tend to go off half-cocked in many cases. They don't think it through. Just one example in my own research, they're one of the things that bothers evolutionists is that there's this mountain range in Antarctica that has almost no erosion. And they came up with these trial balloon theories to explain how it could have no erosion. And they actually said, oh, yeah, we solved it. Well, about a year later, they came up with another solution. Well, what does that tell you? It tells you their first solution wasn't any good, even though they had claimed in the popular science press they had solved it. So just because you see some of these articles claiming, oh, yeah, we solved this, or we think we've got this solved, doesn't necessarily mean that that's the case. And especially in the popular science literature, claims are often hyped, and they often don't stand up to scrutiny.
I feel like we live in an era where consensus determines reality instead of the other way around. Right. Reality should determine consensus. And it gets really easy for people, whether they are Christians who want to believe what Scripture says, whether they are evolutionists, even atheists who really want to reject a God. It gets really easy for people, everyone, to just listen to the consensus, and it's being said over and over and over and over again. And it's easy to start thinking that that's correct because it's the consensus.
Right.
So how would you encourage our listeners against that, whether they are a firm believer in biblical creation, whether they are on the fence about some of these things, or even convinced that evolution and the Big Bang and the anti-God theory is all true? How would you encourage or challenge our listeners?
Well, the thing is, once you step outside your area of expertise, even scientists are lay people. And so if we're really honest about it, we take things on faith. Now, the evidence, oh, no, I don't take anything on faith. Yeah, you do. Anytime you accept another scientist's word about an experiment that you did not yourself conduct, you didn't replicate, or, if you're looking at paleontology, they're describing how they found the bones. They're describing the geological setting in which the bones were found, and you're taking their word for it. Okay, even if you're another paleontologist, you're not going to travel over there and redo that dig. You're just not. And so whether we like to admit it or not, we have to take things on faith. And I think even for, people say, oh, well, I believe in evolution because of the science. I don't think that's quite right. I think the real reason you believe in evolution is because scientists are telling you it's correct. And honestly, I think that's the reason most scientists do it. They've got these people that they think are authority figures who are telling them there's all this evidence for it, and they're assuming that it's correct. And I think Christians. I'll give you an example. I got an email just yesterday from somebody had basically thrown a paper in front of him and said, "How do you explain this? This proves radioactive dating is correct." And the thinking seems to be that as creationists, we're supposed to scramble, drop everything we're doing, and try to come up with an answer to that. And I suggested, well, maybe you ought to flip the script on this guy. Maybe you ought to ask this guy who's telling you that this is proof for an old Earth. You tell me what the assumptions are in this paper. You explain it to me. Tell me how it works. Tell me what the assumptions are. How much you want to bet he probably can't do it. And so, I've seen this a lot. Old Earthers will tend to throw up a graph, and they think we're just supposed to curl up into the fetal position and reject a literal genesis because they put a graph up on a screen. Come on. What assumptions went into that graph? Where did it come from? And I actually, we went through an exercise once where BioLogos had published a paper that they claimed was super strong evidence for an old Earth. And they had been beating creationists over the head with this one particular graph for about 6 years. And it looked kind of convincing. It looked like a convincing argument for an old Earth. It had to do with these varves in a Japanese lake. They claimed that there were these at least 50,000 annual layers in a Japanese lake, and supposedly that proved the Earth had to be at least 50,000 years old. And they were beating creationists over the head with that. I mean, I know there were creationists who said that they would be at speaking events, and these guys would come up, shove this graph in their face, and say, you need to interact with this. You need to interact with this data. Okay, so guess what? We finally did that. It's not like we didn't have anything else to do. But in 2016, I said, okay, we're going to take a look at this, and we're going to look at this. And so I started digging into that paper and found, frankly, that it was junk. It was garbage. But it looked convincing. And we embarrassed them pretty badly because they ended up taking down that paper from the BioLogos website, but without explanation. Now, unfortunately, they put up another paper that makes the same argument, but in a disguised form. So, it's like a whack-a-mole, It's really pathetic. This is what we as creationists are up against, and I don't think people appreciate this. It was more work to refute that bad argument than it was for them to make the bad argument in the first place. And after we refuted it, then they took it down so nobody could see how badly they messed up. That's the kind of thing we're dealing with. So you can have arguments that look very convincing, and they can still be completely wrong. And I think creationists need to be not so intimidated when evolutionists shove stuff in their face and say, how do you explain this? You need to flip the script on them and say, all right, you tell me. You're telling me that I should abandon a straightforward understanding of Scripture based on this. You tell me what the assumptions were. You tell me how this was derived. How much you want to bet? In most cases, they can't do it. And so it's just, I think we need to be a little more hard-nosed. We're learning, I think. We've learned in the last few years that the scientific establishment cannot always be trusted. We found out the hard way with COVID-19. They were playing politics with a literal life and death issue. And if they're willing to do that on something that is literally life and death, a global pandemic, then I think you've got to consider the possibility they might play politics with other stuff too. And so I think Christians and really just people in general need to be a little more hard-nosed and not so gullible when it comes to the claims that these people make.
And we can be properly confident because literally the God of the universe has given us his word and it lines up with the evidence. We don't have to be embarrassed. Paul talks about not being ashamed of the gospel of Christ.
Right.
The gospel of Christ is built on the foundation of Genesis.
Right.
We don't have to be ashamed of any of that.
Well, and the sense I'm getting doing creation research is the case for creation, and not just intelligent design, but the case for biblical creation, a recent creation about 6,000 years ago with a literal worldwide global flood. That case is getting stronger all the time. Now, the popular perception among creationists or among Christians is the exact opposite. That we're being pushed up against a wall and it's getting more and more desperate and the case for creation is getting weaker and weaker and they're chipping away at our arguments. That's totally wrong. It is totally wrong. It's the exact opposite.
They're picking up a grain of sand off of this pile and throwing it away while we're building with this giant boulder over here.
And I'm not exaggerating when I say that. The case is getting stronger. We are answering questions that people thought we could never answer. And so, I would urge Christians not to be intimidated when people essentially try to bully you into accepting claims, that are dubious.
Moral of the story, you can trust your Bible, folks.
Right, you can.
You really can. It lines up with the evidence.
Yeah.
Absolutely. Well, this has been really encouraging and super informative. I honestly didn't know a lot about these 4 moons, these Galilean moons, before talking with you today. So this has been really, really encouraging for me, and just talking with all of our scientists here and also other guests we have on some of our other podcasts. It's just always showing me that no matter where you look in our universe, you see God there. You see evidence that you can trust what he has written in his word.
Yeah.
So any final thoughts before we close today?
Not really. Like I said, it's not just Jupiter's moons. Saturn's moons look young. There's a lot of problems. If you're an evolutionist and you want to believe that the moons of Saturn are old, you got a lot of problems there too. So when you look in our solar system, it really does look young. And of course, and I understand, people with distance, people get hung up on distant starlight, and that's something we're still working on. But when you look at our solar, it really, really looks young. And I think the preponderance of the evidence favors recent creation. And like I said, we're working on the distant starlight issue. And the problem with that is, even if we find out the correct answer, we may not be able to prove it, because you're talking about stuff that is so far away, we can't ever go there. We can't really ever send a probe.
But neither
there.
can those who
Right, they can't either. Everybody's making assumptions. The problem with that argument is you're making even more assumptions than you are with these other arguments. And so very subtle assumptions. And so,
absolutely. Yeah. Absolutely. Well, Dr. Hebert, thank you so much for being on the show today and talking about these issues. I really appreciate your insights.
Well, thank you so much for having me, Lauren.
So to our viewers and listeners, thank you so much for joining us. We hope that this was informative and encouraging to you. And just think about these issues. And there are a lot of people out there, whether they are Christians or they're not, that are really passionate about outer space and the solar system. So if you think of them, send this podcast to them, and maybe it'll help encourage them if they're a believer, or maybe just challenge them and make them ask questions if they don't currently believe what the Bible says. So regardless, be sure to like, subscribe, and you can view this podcast and listen to it anywhere you normally listen to your podcast, Spotify, YouTube, and more. And we will see you next time on the Creation Podcast.
We want to say a huge thank you to our members and patrons. If you'd like to see your name here and unlock perks like early access to our podcasts, members-only polls and live streams, behind-the-scenes footage, or exclusive video content, links are in the description below.